Oh, welcome again and thank you for joining. We'll continue with example number 4 from lesson 2. We are exploring how to use the second derivative to predict the shape of the graph of a function. So in this example, we have to find the coefficient c such that the function f of x equals cx squared plus x to the negative 2, power negative 2, has a point of inflection at 1 f of 1. So a couple of things that were given in here. First of all, the function has an unknown coefficient. And we are told that the function has a point of inflection at x equals 1. So a point of inflection occurs wherever the second derivative is equal to 0. And having a point of inflection at x equals 1 means that the second derivative at x equals 1 must have a value of 0. So in order to use this piece of information, that means we have to find the derivative of the function. So we'll start off with the first derivative first. So remember, this is just a constant number, so it's not a changing number, so it doesn't play part in differentiating. Only variables change, only they have rate of change as a result. So we have c, and then the derivative of x squared is 2x, and then plus, again, it's power rule, so negative 2 becomes a coefficient, negative 2, and then x will be to the power of 1 less than negative 2. In a more simplified form, we'll say that f prime x is 2cx minus 2x to the power of negative 3. Next, we have to find the second derivative. F second x would be equal to, so remember that now x is to the power of 1, 2c is the coefficient, which means that the derivative of 2cx will be simply the coefficient 2c. The derivative of negative 2x to the power negative 3 will have the coefficient negative 2, and then we'll multiply by coefficient negative 3, so the exponent becomes a coefficient of x, and the exponent of negative 3 will be decreased by 1. So simplified, and we have 2c, negative 2 and negative 3 can join each other. They will give a product of 6, and then x to the power of negative 4. Now we are told that the second derivative will be equal to 0 at x equals 1. So in other words, f second at 1, which is practically equal to 2c plus 6. So remember that wherever we see x now, we're replacing it by number 1, which means this x in here will be replaced by number 1 as well, to the power of negative 4. We'll have a value of 0. So we have 2c plus 6 equal to 0. 2c equals negative 6. So that will make c equal to negative 3. Therefore, we're going to say that if c equals negative 3, then yes, the function will have an inflection point at x equals 1. I hope this made sense, and thank you for watching. Bye for now.